Hey everybody, this is Larry, this is me going Q2 of the bi-weekly contest 159, find maximum area of a triangle. Hit the like button, the subscribe button, join me on Discord, let me know what you think about this one. So this one, it is a little bit awkward. I think the first thing to notice is that there's this twice area. It's just to make it easier so that you don't have to do like fractions or anything, it'll be exactly represented because it's divided by 2, but it should be fine, right? So now you have, instead of the area of the triangle, you have the area of parallelogram. I initially thought that maybe I have to figure out something with either the dot product or the cross product. I always forget which is which, to be honest. I think cross product is the one, but and then just do math from that. But of course, n is big, so you have to be a little bit smarter because you can't do every cross product, right? But then the next thing I noticed is that one side has to be parallel to x or y. So that makes it actually a different problem and a much easier problem. And often for graph problems, I talk about visualization, and here it is, right? Here's a good one. And we will draw on it in a sec. But yeah, I thought this was a very good way to kind of force people to illustrate to visualize, sorry. But basically, I guess I don't need to copy and paste this. Okay, so yeah, so in this problem, there are a lot of points, right? And you have to choose some axis aligned ones, right? And without loss of generality, we'll just go over one dimension because you can, flip it the other way, in which we actually do, right? But basically, the idea is that, okay, well, given the same x, oops, what happened to my mouse? All right, what happened to my thingy? All right, stop it. Okay. Yes, given the same x, well, what are you going to do? Well, let's say this is the base of the triangle. If this is the base of the triangle, then I think it's pretty easy to visualize that you want the base to be as long as possible, right? Because, let me change the colors real quick. Because if this is the base, then it doesn't ever make sense to say choose this subsection, right? So that means that now for any given x, we want the highest point and the lowest point, because now we're choosing this side to be axis aligned, right? A vertical line. And like I said, you could choose a horizontal line without loss of generality. But we call that the triangle, especially 2 times the triangle, is just going to be width times height, right? Or base times height or whatever. And here you have the height. Well, technically this is the base. Maybe I should have done it in the other dimension. But in any case, notice that in this part here, maybe we'll draw a couple more points, and even like all the way down here for whatever reason. You could see that if we're drawing from here to here, the triangles all have the same area, right? You could here, even all the way here, even though it looks very skinny, or even this one. Oops, not that one. Let me change the color real quick. Pretend they're straight lines, right? They all have the same area, right? You don't have to do it point by point. It only matters, right? And like I said, maybe if you can flip it, then this looks more obvious. But in any case, right? And if the formula bears it out, right? Because it is just the base times the height. And this is something that you may learn in geometry very early on, so I don't know how much to go detail into this part, especially since I'm not a big geometry person, to be frank. So I don't know how to do I don't know how to like do all the proofs or whatever or not anyway. But in any case, so now that you see that they're all the same, then now what? Well, because they're all the same within the same line, then now we just want to go also in a greedy way as most as possible to the right. And also as much as possible to the left, possibly, right? Depending on which line you picked. For this one, obviously, actually, it's just this line. But if you're checking a same line that's here, then now you definitely want to go the one that's all the way to the left. And that's the general core idea behind this problem. Yeah. And so, without further ado, let's take a look at the code. Yeah, so this is basically given a coordinate. I sort. The reason you don't need. I don't know. Sorting is fine. You don't need to sort. I just like sorting because it's n log n, and it's n log n is fine. But I think I only sort so that I could do a min x and min min x and max x in O of 1, right? Because here it chooses the leftmost point and the rightmost point, right? Yeah, let me write it down. Leftmost point, rightmost point, right? And it, like I said, the height doesn't matter. It just happens, you know, it has to be the leftmost and rightmost. And then here I keep track of all the y's for a given x. And honestly, I was a little bit lazy, and when you watch the live part, I actually talk about this, how lazy I was. You probably could keep track of, for a given y, instead of keeping track of list, you only need to keep track of two things, the min and the max. But I did it later, so as you can see, for each key, I take the top as the max, bottom is the min, so this is the height. And then the width is just, yeah, you go all the way to the left, or you go all the way to the right. And that's it. And then the best is just, we update best to the height times width, divided by 2 to get the triangle, but then you times it by 2 for the problem, right? And again, this is just for leftmost and rightmost, so how do we do it? Well, like I said, to get the other dimension, you flip it to the other side, so then now your x becomes y, and y is equal to x. So in other words, xy is equal to, or x comma y is equal to y comma x. Is the transformation, and you can see that I do that here, right? For xy, I transform it to yx, and I just calculate it again, and then yeah, we get the max out of those two ways. If it's, you know, if there's no area, or if it's -1, then just return -1. Otherwise, we return it all, and that's it. I was a little bit lazy. I keep saying I'm lazy, but I just wanted to go for speed, right? So I end up doing this in about 8 minutes. I just thought it would end up more typing, even though I take my time on these things these days. But yeah, so what I mean by that is that, okay, there is sorting so that I can do this, but and this is n log n, but you can actually just rewrite this very quickly with like something like yeah, you can rewrite this with a loop, right? So for x, y, and coordinates, leftmost is going to be infinity, rightmost is going to be negative infinity, and then here, you know, right? So that's it, right? Same thing, I think, unless I made a mistake. But the idea is the same, right? Which is that you're just trying to get the min, the max, and why I did that is so that now it is not n log n. This is now O of n, and obviously so, right? And again, yeah, everything else is O of n, so that means that this is O of n. The transformation is also O of n. We call O of n a couple of times. So yeah, this is a linear time, linear space algorithm, and that's it. Let me show you the top, show you the meat of the function, and then show you the bottom, and that's it. That's all I have for this one. Let me know what you think. Thanks for watching, and you can watch me solve it live in a contest now. But with time's out, then I'll be a little bit sad. Okay, that was kind of harder than I expected for Q1. Definitely a little bit slower. I don't even know how much time I did, but 7 minutes for Q1 is a little bit slow. Okay, and by 2 coordinates, find twice the maximum area of a triangle with any coordinates. Why twice the triangle? I guess so that you don't have to divide it by 2. That's kind of cute. And it's just all, I was gonna say dot product. Is it dot product or cross product? Area of a triangle. Oh, it has to be parallel. At least one of the sides is parallel, huh? And no zero area. Okay. That makes it interesting, the parallel part. Okay. So let's say we have all the x's. Okay, so the parallel part actually makes it easier because you want to maximize the base anyway. So then, and then what? And then how do you get the height? Height doesn't, so the height doesn't really matter. So then for each width, okay, actually that's not so bad. That's interesting. That's a cute problem. Okay. Hold on, I want to write it. How do I want to write it? Here's the one I want. Min x. Min x is equal to infinity, max x is equal to infinity. And then basically now, so for each x, we'll wrap it. So for each x, we want no. So this then we want min y x y, all right? Because then now for each x, we want to get the min and the max of that, right? So okay. I mean, I'm gonna write it in a lazy way. I think you're not supposed to use the list, but I'm just too lazy. X. And you could probably sort actually, but sort the input. It's fine. I'm lazy. Okay, then now, oh yeah. No, it has to be. This is so annoying because then now you have to keep track of the top two type thing, which is not that bad, but just annoying. Wait, do we want? No, we want. No. Wait. So for the same x, I'm getting my okay. For the same x, we append the y. No, for the same x, we append the y. So then now we want to for this. Okay, no, that's not bad. No, I had it right the first time. It's just so confusing. Then now actually we should do coordinates.sort, because then now min x is just equal to coordinates of 0 or 0. Something like that, right? And then now for okay, yeah, for x in the keys, x, so we want the max of this because this returns the y's. So okay, that's why I got confused. This should be a y's, maybe. So this is the top, so top is equal to this, bottom is equal to this. We could have done it here and it'll be slightly faster, but it's okay. And then now, okay, so that's the height. Now we have to get the width, which is either times x minus mx. Okay, so let's just get what did I say, width? That's height actually. Max the min x or this, right? And then best is equal to max best height times width, return best. Alright, okay. I need some. I'm always worried about performance. Also, I messed this up. Where you use the mess up apparently. Oh no, this one has to be because I'm doing it through the thing. Maybe that'll be okay for now. So we Cannot be 0. So I don't even keep track of this. Good. Okay. So then now we can do. No. We want maximum area. Let's do negative and no. So just stupid 0. I guess 0 is fine actually. Max R1, R2. I feel like I'm very slow today. 2, -1, YOLO submit. Hopefully, okay, good. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, today's contest, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.